What do I still need there? I have the x under there. I need the 4. I need a 4 there, don't I? How can I introduce a 4? Same thing, but see, this time I'm not putting 4x, I'm just putting 4. 4 over 4. And then I'm going to take that 4 and slide that underneath here with the x. I love these problems. I mean, there's so many things in math classes that are so like mechanical, like monkey see, monkey do. You know, I show you, now you do. These problems are a little, they require a little more intuition. You just kind of got to mess around with it. So what would I have now if I did all that? Sine 4x over 4x, which I'm very happy about because that's going to turn into a 1. Then x over, or 6x over sine 6x. I'm happy about that because that's going to be a 1. What's still out here? A 1 over 6, because I slid that x over, the x isn't there. And then what's over here? 4 over, I slid the 4 over, so there's a 1 down there, isn't there? Does everyone realize the only thing on that 4 over 4, the only thing I pulled over there was the 4 on the bottom, right? The 4 on the top stayed. And now I'm going to apply the limit. So that means no more limit. I'm just going to tell you what each of these becomes. That becomes a 1 times that becomes a 1 times that becomes a 1/6, and that becomes a 1/4, or 4 over 1. And so your final answer is what? 2/3. These problems are pretty neat. Yeah, you'll have one like this. Yeah. The sine 4x over sine. What do you mean? The very beginning? Like coincident? You mean the 4 over 6? That's a good question. I think what's being asked is, hey, look, our final answer was 2/3, and that's just like these two numbers, right? So like, couldn't you just put like those two numbers? There are times when that will happen, and there are times when it won't. So it's not. I had a student, I think last year, who asked me the same thing, and I said, and she was adamant that, look, it'll always work. And I said, then do it, prove it in general. You have to be able to prove that. Like use a and a b, like sine ax, sine bx, and then show that it'll always turn out to be a over b. Let me give you one that's completely different than this, just so you can see, like, you might start to look for patterns, but they don't necessarily always, they're not always there. All right. This will be number 52. But that was good to see that, though. Limit theta goes to 0. Cosine theta minus 1 over sine theta. So real quick, substitution here. Theta goes to 0. What's cosine of 0? 1 minus 1 is 0. Sine of 0, 0. So 0 over 0, we've got problems. So what have I been doing? I've been like splitting it apart, right? So let me try and split this. I'm going to go cosine theta minus 1 over 1 times 1 over sine theta. When the calculus faculty were together and we were selecting books, one reason I didn't like this book is because the problems we're doing right here, there are only numbers 49 through 56 in the book, where a lot of other calculus books, this is an entire section, just this. I don't think this book goes deep enough into this sort of thing, but oh well. So that's fair to do that? Where's the thing causing the problem? The sine theta. So what would it be just great to have above it? Just a theta. So let me introduce a theta over theta. But I just created the new problem, didn't I? Like the theta on top is going to fix the sine theta, but then the theta on the bottom is going to cause an issue. However, what? So I know I can slide this one over here. Remember there were two formulas you needed to know? Wasn't the other formula cosine theta minus 1 over theta, or cosine x minus 1 over x? So can I just slide that theta underneath this? So wouldn't this become limit theta goes to 0, cosine theta minus 1 over theta times theta over sine theta? And both of those are formulas. What does the first one go to? That goes to 0 times, what does this go to? 1. So the answer is 0. Yes. Wonderful question. It does not. Okay? The question was, does this formula, where is it? This formula right here. Question was, does this one flip over? And the answer is no. Now, I can tell you why. I think the easiest way to tell you why is to show you the first one. Well, let me show it to you this way. The first one, like this, I told you that this one would still be 1, right? I told you that would still be 1. Here's why. Because if I take this and rewrite it, isn't 1 divided by sine x divided by x the same as x over sine x? Like in other words, if you take this fraction would flip and the x would go on top. So these are the same thing. And then there was a property of limits that said if I'm taking the limit of a fraction, top and bottom, I can do the limit on top and bottom separately. What's the limit of 1? Just 1. What's the limit of the bottom one? 1 again. Right? This one is the junk over junk. So you get 1 over 1. If you try and do the same thing with the cosine x minus 1 over x, this one right here, then you'd rewrite that as 1 over cosine x minus 1 over x. Are you following what I did there? Now, if I do limit on top and bottom, I get 1 on the top, but what do I get on the bottom? What is this? 0, and you get division by 0. So you can't flip it. Okay. That's just a little side note. Not everyone needs to know that. All right. Well, man. Yeah, you've got a couple of problems from there. Let me just see. We've got, boy, this class is long. We've got continuity still to talk about. I think we'll be able to knock continuity out pretty quick next time we're in class. So I'm not worried that we'll be a section behind. Just looking for something here. How about we do this? I don't want to get us into a habit of cutting out a class this early. So how about I give you a maybe just like a 2-question little set to do. You do it, you show it to me. If it's good, you go. All right? Just a little exercise. So let's try. You're not going to turn this in, but I need to see it before you go. Sketch. Whoa. What the heck's going on here? Sketch a function that has these properties. A, limit x approaches -2 of the function equals 1. F of -2 equals 4. Limit x approaches 0 from the left of the function is -1. Limit x approaches 0 from the right of the function is 1. F of 0 undefined. Okay, that's the first problem. The second one I'll put next to this. Find limit x approaches 2 square root. I have to think about this for a second. X plus 2 minus 2 over x minus 2. There you go. And just so you know, I'm going to leave the problems up for a minute. Well, let me just let you all write it down. Make sure you write them down because I'm going to take them off the board here in just a second. Anybody still writing down the problems? Everyone's got them? That's your stuff for next time. So and I'll leave this up so you can get this at the end. But you've got homework assignments. Just do the 1.4 and 1.5. I mean, sorry, we didn't do 1.5, right? So do not worry right now about the 1.5. You don't have to do it, but you may as well write the problems down because that's what I'm going to ask you to do. Make sure you watch the videos for 1.6 and 2.1 because we are going to catch up. And remember I said to get your IP address and stuff, and make sure you print your notes for Chapter 2 because we'll start Chapter 2 next class. All right, I'm going to stop the recording, but I'm going to leave that up there.